So remember with solving, one strategy, particularly if we only have one log in the equation, is to just put it in exponential form. Okay, so it's much easier to solve it if it's in exponential form. And so I have a base of 5, I have an exponent of 2, and that is equal to the argument, which is 2x minus 3. And then I can just solve. So we can just apply our power, add 3, and then solve for x. Okay, so if it's just one log, it's pretty simple. Just put it in exponential form. Question 2 here, if you have 2 logs, then you want to combine them together to get 1 log. So we're going to use our laws of logs to combine. So it is subtraction, so we will switch that to division. That's not an x, that's a 3. So it'll be x divided by x minus 4. And then once I have that 1 log combined, then I can put it in exponential form. So it's base 3 to the power 2. And then we want to solve. So if we're solving for this one, we can just cross multiply. Remember that 9's over 1. So it'll be 1 times x equals 9 times x minus 4. And then we'll just expand brackets. And I'm going to put my variables to the right side. So it'll be 9x minus x. And then we'll divide. And you can leave it as a fractional. That's an exact answer. Just make sure it's in lowest terms. Actually, that would be lower than that. It can be divided by 4. So 9 over 2 is what I meant to say. 8 reduces to 9 over 2. Okay, so if you have 1 log, just put it directly into log form. If you have 2 logs, combine them and then put into exponential form. Let's see this one. So here we have 2 logs, but they're not on the same side. So let's get them on the same side. So I'm going to bring this minus log 2x to the left, so it's plus log 2x. And then we have 2 logs on the left. We're going to switch addition to multiplication, so that we have 1 log, and then we can put it in exponential form. And then we just have to solve. So 2 to the power 4 is 16. On the right side, I get x squared minus 6x. Since we are solving, we need to get everything on one side because it is a quadratic, and then we should be able to factor it. So 8 2's are 16. It has to be minus 6, so minus 8 plus 2. And then we check for extraneous roots, which I forgot to do in the last 2 questions, so we'll go back. So extraneous roots, when we sub it back in, we need to have a positive argument. So if I put 8 in here, I get 8 minus 6 is 2. That's okay. If I put 8 in here, that is 8. So 8 is fine. If I put negative 2 in here, I get a negative result. So that is an extraneous root. So that is not a valid root. Now let's go back to the last question. Our answer was 14. 2 times 14 minus 3 is a positive result, so that's okay. In this case, we got 9 over 2, so it's okay for that. 9 over 2 minus 4 is still a positive result, so that's okay. So this solution is valid as well. Okay, so those are just solving. If it's in log form, put in exponential, use your log laws to combine if you need to, and then just solve. We did look at these. So if they're not in log form and they have different bases, we need to log both sides. So we need to put it in log form. So we'll log the left and then we'll log the right. Then we want to bring down the powers because the variable is in the exponent, so we need it to come down. So we'll bring it down. Make sure you put it in brackets. I'm looking at some people's work and they're not putting it in brackets. If you don't put it in brackets, it's not really correct, right? Because if I write it like this, that means that only the 1 is multiplied by the log 4 and not the 2x, right? I need these brackets to determine that both 2x minus 1 and log. So even though you're getting the right answer, you're making an error, right? It's not really correct. So I'll expand brackets and do the same on the right. So it's x log 3 plus 2 log 3. Okay. Once I've done that, I want to get all the terms that contain a variable on the same side. So I'm going to bring them over to the left. So I'll bring this minus x log 3 to the left, and then we'll take the minus log 4 to the right. Okay, once I've brought all my variables and collected them on one side, I'm going to factor out the x. And then we're going to isolate and put it back together so that it is in log form. So when I put it back together, put the 2 back up. That is 3 to the power 2 is 9 times 4 because we're adding. So we'll switch addition to multiplication. So 8 and then times 4 is 32. And we'll do the same on the bottom. We're bringing the 4 or the 2 back up. So 4 to the power 2 is 16. And then subtraction becomes division, so divided by 3. So this is my answer in log form. So once you've isolated for x, you have to put it back together using your log laws. Oh, I think I have something here. So you know that, okay. Okay. Or you could always try to log off Zenobia and log back in as well if you have some issues. Okay, so same thing here. Let's do a different color. So I'm going to log both sides. Right, log both sides because I don't have the same base and I want it in log form. And then we bring down the power. Make sure we put it in brackets. Expand our brackets so that we can get all our terms. So x log 3 minus log 3. Bring your variables to one side. I'm going to take it to the right side this time, just for something different. So I'll put the log 2 and the log 3 on the left. And I'll put the x log 2 on the right. And then we will factor out the variable x. And then we want to isolate for x, so we're dividing, right? We want to get rid of this. Put it on this side. I didn't write that step in the previous question because I was running out of room. I was trying to save space. Okay, and then I got to put it back together. So addition becomes multiplication, so 2 times 3. And subtraction becomes division, so 3 over 2. If you put the variable on the other side, you will end up with this result. The 6 will become 1 over 6, and the 3 over 2 will be 2 over 3. Okay? So that's if you put the variable on the other side, you'll get the reciprocals. Okay, any questions on that so far? Okay, let's try a question where we have 2 bases on the left and 2 on the right. So the previous question, we had 1 base of 4 on the left and we had 1 base of 3 on the right. In this question, we have 2 bases on the left and 2 on the right. We cannot multiply these together. Okay, you cannot multiply 3 times 5 and get 15, or 4 times 7 and get 28, because that's not really a 5, right? If you multiply it by 5, you're assuming it's 5, but it's not. It's 5 with a power of 2x. So there's only one condition that would be 5, and that would be if x was a half, because 2 times a half is 1, and 5 to the power 1 is 5. So it is not 5. It is 5 to a power. So you cannot multiply. And I guarantee you that some people will, because they'll forget, but make sure if you can't remember, write a note. I've already had somebody multiply it. So we're going to do what we did in the previous question. We're going to log both sides. Oops, I need a log. Okay, now keep in mind that the 2x, the exponent 2x, only belongs to the 5 and not the 3. Okay, it has brackets around it. So it's not 3 to the power x, it's just 5 to the power x. And the same on the right. The 7 and the power x plus 3 belong together, not the 4. So in order to make sure that applies, we're going to separate terms before we bring down the power. If you bring down the power now, then you're applying that power to both terms. Right, so you want to wait. We're going to separate. So we're going to do log 3 plus log 5. So we're changing multiplication to addition, and the same on the right. We're going to do log 4 plus log 7. Okay, so we log both sides, we separate terms, and then we're going to bring down any powers. So now I can bring this down, and now I can bring this down. Okay, so then it becomes just like the other question. So there's just that extra step as the previous question in that you need to separate terms before we bring down the powers. Other than that, it's exactly the same. So at this point, I'm going to expand any brackets. Then we want to bring terms that contain a variable to the same side. So I'm going to go to the left. And any terms that don't contain a variable, I'm going to move to the right. Then we will factor out the x. And I'm going to start putting things back up. So I'm going to put the 7 to the power 3 back up. So 7 to the power 3 is 343. And then we'll isolate for x. So we're going to start putting these back together. This is 343. Before, I'm just going to bring this 2 back up. So you can do things, and you can do more than one thing in each step. So I tend to put my powers back up as I'm moving things, kind of kill 2 birds with 1 stone. All right, so put the 5 back, or the 2 back up, gives me 25. And then in the numerator, we're going to have 4 times 343 is 1372 divided by 3. Right, so multiplication, addition becomes multiplication, subtraction becomes division, and then in the denominator, we would have 25 over 7. Or if you went the other side, you would have 3 over 1372 and 7 over 25. Okay, so both are the same. You're going to get the same result regardless of whether you isolated the variable to the left or you isolated the variable to the right.